In this video, we'll discuss mathematical expressions and formulas. Now let's start with some definitions. A variable is a letter or other symbol that stands for any number within a specified set of numbers. So for an example, think of the area of a circle. We have the A, which is the variable representing the area, and R representing the radius. That can be of any length greater than 0 since it's a measurement. Now, an expression is a meaningful string of numbers, operations, and possibly variables. Here are two examples of expressions. The first one is called a numerical expression because it is an expression made up solely of numbers. The second one we think of as an algebraic expression because we have variables integrated into this expression. Now, formulas are mathematical rules written using symbols and are usually in the form of an equation that describe the relationship between quantities. Here we have the area of a rectangle. We say that is length times width, and those two values can vary. The area of a circle is another formula that we often use to find that area, pi r squared. Now, when we simplify an expression, we're going to combine all of our like terms. We have to always follow the order of operations, and we have to pay special attention when we have variables because we can only add and subtract identical variables. Let's look at some examples. Say we have 13 times 5 minus 8 divided by 2. Here we follow our order of operations, which says do multiplication and division left to right. So we start with the leftmost operation there, which is 13 times 5. Then we go to the rightmost operation, which was 8 divided by 2. Now we can move to subtraction, which would end up with a solution of 61. That would be simplified for this expression. Now what if we have an algebraic expression such as this, where we have 12x times 3y plus 9 times 5x minus 13xy. First, we're going to do all of our multiplication and division left to right. So here we have multiplication, and then we have another multiplication here. When we do that, 12 times 3 is 36, and then we have x times y. Then we have 9 times 5 is 45. Now we're down to all addition and subtraction between the different terms. At this point, we can only add or subtract identical variables. So we look at what's identical. It has to be xy and xy. So 36 minus 13 gives us 23 plus 45x. This does not have xy, hence why it is only added on as a separate term in the expression. Now we can also be provided values that we would substitute in for a given variable and simplify an expression or a formula. We just want to follow our order of operations as we do this. For example, say we want to evaluate 4x minus 7y when x is 5 and y is 6. This tells us to substitute in 5 for x and 6 for y. That would leave us with 4 times 5 minus 7 times 6. Now we have a numerical expression. We're going to follow our order of operations. We're going to do the multiplication left to right. 4 times 5 is 20. 7 times 6 is 42. Then we simplify our subtraction to give us negative 22. We can also simplify expressions with fractions. Just pay attention to our order of operations, as well as when we have multiplication of two fractions, see if you can simplify the numerator and denominator. For example, say we have 18 19ths times 19 23rds. Separately, the fractions are in simplified form, but now I'm multiplying them together, and I can see that I have 19 over 19. These simplify to 1. This leaves me with a simplified fraction of 18 23rds. Now you may be asking, how is this possible? Think about the commutative property because this is multiplication. When we multiply fractions, we are actually multiplying the numerators and multiplying the denominators. This allows us, though, to recognize that we can change the order using the commutative property, and we're going to do that in our denominator. This would then leave us with 18 23rds times 19/19 because I can both combine and separate into the individual fractions being multiplied. Then 19/19 leaves us with 1, hence why it's 18/23. Let's look at another example. Say we have 18/19 times 7/24. Again, each fraction is simplified, but if I look at the other parts of the numerator, 18 and 24 can actually be simplified together. Again, because this is multiplication. They are both divisible by 6, so 18 divided by 6 is 3, 24 divided by 6 is 4. Now I can multiply my numerators and multiply my denominators. This will leave me with 2176. And again, this is nice because it simplifies most of the problem along the way as we're solving. Now, one of the key things that can be very helpful is using our expressions to help us build from story problems. And it can be an expression, and later it can be looking at an equation. But we pay attention solely to what's happening in the problem. So say I have this problem where it says, I put some money in a bank account. I remove 2/3 of my money. I then put $35 back in my account. How much money is in my account? This part here, some money, tells us we're starting with an unknown amount. So we can only create an expression. And to create the expression, we're going to go one action at a time in the order they appear in the problem. So the first thing that I'm told is that I have some money in a bank account. That's the unknown. So I'm going to give it a variable. In this case, I'm going to call it M. The next thing is I'm removing 2/3 of my money. So I am subtracting 2/3 of the amount in the account. That would be 1M minus 2/3 of M because that's the amount in the account. I would simplify that fraction and say that is 1/3 M. Lastly, I put $35 back in my account. So I am adding $35 into the remaining, which will leave me with 1/3 M plus 35. And that's as simple as this expression can get based on the information that I have in this problem. Let's look at one more example. Suppose I have some money in a bank account. One day I deposit $20. The next day I remove 1/4 of the money in the account. How much money is left in the account? Again, we start with an unknown starting amount, so we're going to create an expression. We're going to simplify again one action at a time as they're described in the order of the problem. So we have some money in a bank account. Again, we're going to call that M because that's unknown. Then one day, deposit $20. That's adding $20 into the account. So that's M plus 20. The next day, I remove 1/4 of the money in the account. Removing is subtracting, but I'm subtracting 1/4 of that total amount in the account. Well, what's the total amount in the account? It's the M plus 20. So I'm subtracting 1/4 of 1M plus 20. Now I want to distribute that 1/4 to both terms. So this will become 1/4 M and this will become minus 5. Remember to distribute that negative as well. Now following my order of operations with expressions, I can say 1M minus 1/4 M is 3/4 M, and 20 minus 5 is positive 15. So always pay attention to those order of operations and take it one action at a time.